Hello everyone, today we're going to be talking about graphing rational functions. So first, for some vocabulary, a rational function is a function of the form f of x is equal to p of x over q of x, where p of x and q of x are polynomials. So an example of one would be the inverse variation function, which we talked about last time, which is f of x is equal to a over x. And the parent function for simple rational functions is f of x is equal to 1 over x, and its graph is called a hyperbola. And a hyperbola consists of two symmetrical parts called branches, which you see on the right side here. I see on the left I have this blue graph that's in the third quadrant, and then this another part of the blue graph, which is in the first quadrant. And we see here that we have a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. And so looking at the graph, that means at x equals 0, which we see right here, both of the branches approach it, but they do not touch it. And same with y equals 0. Both branches approach it, but they do not touch it. That's what we mean by asymptote. And we see that the domain and range are all non-zero real numbers. So in other words, x does not equal 0 and y does not equal 0. And that's because the graph is approaching those values but not touching it. And we see that any function of the form g of x is equal to a over x, a not equal to 0, has the same asymptotes, domain, and range. So let's go ahead and practice graphing these rational functions of the form y is equal to a over x. So this first one, we have g of x is equal to 4 over x. So the first step that we want to do is we want to see what our asymptotes are. Well, we know, we just set up here, that any function of the form a over x, where here a is equal to 4, is going to have our asymptotes at x equals 0 and y equals 0. So I'm just going to go ahead and write that. So my asymptotes are x equals 0 and y equals 0. And we could go ahead and draw on that graph, but that's just our x and y axis. So looking at making a table, we have x and y. And we want to choose some points that are on the left-hand side of our vertical asymptote and on the right-hand side. So our vertical asymptote is x equals 0. So three values to the left of that are -3, -2, -1. And three values to the right are 1, 2, and 3. And the reason why we can't put 0 in there, because if I were to put x equals 0, I would get 4 divided by 0. And remember, we can never divide by 0. That gives us an undefined value. If you put it into Desmos or into your calculator, it's going to give you an error message because that is not possible. And so that's why we need to choose values to the right and left of it. So when I plug in -3, I get 4 over -3. When I plug in -2, I get 4 over -2, which is just equal to -2. When I plug in -1, I get 4 divided by -1, which is -4. Plug in 1, I get 4 divided by 1, which is 4. And then 4 divided by 2, which is 2. And then 4 over 3. So now we can go ahead and graph this function. So my first point, I have -3 and 4 over -3. So -3, and then I'm going to 4/3, so that is a little bit over -1. At -2, I go to -2, and then -1, -4, 1, 4, 2, 2, and 3 4/3. So I end up with these points, and now my last step is I need to draw those two branches of the hyperbola. And here we need to follow what our asymptotes are. So our asymptotes are at x equals 0, y equals 0. So in other words, the x and y axis. So that means I'm going to follow along both of those axes, but I'm not going to touch it. So these branches end up being contained inside of those. Okay, let's look at another example. So here I have f of x is equal to negative 6 over x. My first step is to identify my asymptotes. Well, since this is in the form of y is equal to a over x, my asymptotes are at x equals 0 and y equals 0. So in other words, the x and y axis. So now I need to find my points. So I'm going to use the same points that I did before for my x. And now I'm going to plug those into negative 6 over x. So I have negative 6 divided by negative 3, which gets me a positive 2. Negative 6 divided by negative 2, which gets me 3. Negative 6 divided by negative 1, and I get 6. And then I have negative 6 divided by 1 to get me negative 6. Negative 6 divided by 2 to get me negative 3. And then negative 6 divided by 3 to get me negative 2. And so applying those points, I have negative 3, 2, negative 2, 3, and then negative 1, 6, 1, negative 6, 2, negative 3, and then 3, negative 2. Now to draw those branches, and I need to follow where my asymptotes are because I know my function is going to follow along it but not cross it. And so it's my x and y axis. That means I have my first branch looks like this, and then my second branch.